Hey guys, welcome to part 4 of my counting particles series. If you haven't seen the previous 3 videos, 15 through 17, then I suggest you watch that first before moving on. Today we're going to be talking about the percent composition of compounds. Let's get into today's video. First, let's go over last week's problem. We have 25.6 grams of NH2 2CO. We multiply that by 1 mole NH2 2CO over 60.06 grams NH2 2CO, since that's the molar mass. If we cross out the grams, this gives us the number of moles of NH2 2CO that we have. You could have found that value and then used it to do the next part, but I'm just going to combine all the steps. Now, here you have to use something I haven't directly taught you. If you look at NH2 2CO, you see that there are 4 hydrogen atoms, since there's H2 multiplied by 2. That means for every mole of NH2 2CO, there's 4 moles of hydrogen. This cancels out the moles of NH2 2CO and leaves us with the moles of hydrogen. We're still not done though, because we don't want to find the moles of hydrogen. We want to find the number of atoms. So, for the final step, we're going to multiply it by 6.022 times 10 to the 23rd hydrogen atoms for every mole of hydrogen, if you remember that relationship from 2 videos ago. This cancels out the moles of hydrogen and leaves us with the number of atoms. The answer you should have gotten, give or take a few decimal points, is 1.03 times 10 to the 24th atoms of hydrogen. It's alright if you didn't get that right. It's one of the most difficult kinds of problems you'll see in this unit, and I really just wanted to test if you know your relationships. If you got it wrong, at least you learned how to do a problem like this now. Percent composition by mass is the percent by mass of each element in a compound. You basically find this by dividing the mass of the element in 1 mole of the compound by the mass of the compound, and multiply it by 100 to get the percentage. Let's do an example with H2O2. H2O2 has a molar mass of 34.02 grams. H has a molar mass of 1.008 grams, and oxygen has a molar mass of 16 grams. To find the percent composition by mass of hydrogen, you divide the mass of hydrogen in 1 mole of H2O2 by the molar mass of H2O2. Keep in mind that there's 2 hydrogen atoms in this molecule, which means it's not 1.008 grams divided by 34.02 grams, but rather 1.008 grams times 2 divided by 34.02 grams. The whole thing multiplied by 100 tells us that hydrogen is 5.926% of the mass of H2O2. Now you try with oxygen. Let's see if you get it right. Oxygen has a molar mass of 16 grams, but there's 2 moles of oxygen for every mole of H2O2, so we multiply it by 2, and then we divide by 34.02. The whole thing multiplied by 100 tells us that the oxygen makes up 94.06% of the mass of H2O2. Now you try a similar problem. Find the percent composition of hydrogen, phosphorus, and oxygen in phosphoric acid. Phosphoric acid is H3PO4. Some stuff you'll need are the molar masses of the elements and the molar mass of the molecule. I'll make it easy for you and tell you that the molecular mass of phosphoric acid is 97.99 grams. But I suggest you take the time to calculate it, as we learned in the last video, and compare it to the actual answer. You can find the molar masses of the elements on any periodic table. I'm not going to walk you through this answer since it's exactly the same as the previous problem, so pause this video, solve for the percent compositions, and unpause when you're ready to see the answers. Okay. You should have gotten that hydrogen is 3.086% of phosphoric acid by mass. Phosphorus is 31.61%, and oxygen is 65.31%. Did you get it right? Finally, let's do the problem of the day. Find how many kilograms of copper are in 3.71 times 10 to the 3rd kilograms of calcoprite. This time I'm not telling you the molar masses of the molecule. You have to find that yourself without looking it up. I'll give you the answer next week. Let's review. Percent composition by mass is the percent by mass of each element in a compound. We find this by dividing the mass of the element in 1 mole of that compound by the mass of the compound itself. This will give us a ratio. Then we multiply it by 100 to find the percentage. We did a couple different problems today. I know it can be hard to understand, especially if you haven't mastered the ideas from the previous 3 videos, but with practice from your textbook, you'll get it in no time. Be sure to do the practice problem from today and write your answers in the comments below. We'll go over it next week. Please like, share, comment, and subscribe for more videos every week.